Namaste.
Namaste.
I'm Alvin Thomas.
I myself Subhranshu Kumar Singh. We are from the group
Astron.
The demand for energy is at its all-time high and it is predicted to increase in the near future. The excessive dependence on the conventional source of energy as well as the pollution caused by them calls for a more clean and renewable source of energy. It's against this backdrop that we are presenting our power grid as a solution for all power problems of this world, creating gigawatts of energy for this world per year.
For powering the power grid, we need energy, and we will be using the ionospheric part of the atmosphere for the same. And the energy in the ionosphere exists in three forms. The first one is thermoelectricity, and how to harness it. We'll be using the Seebeck effect, which uses the temperature gradient in the atmosphere, that is in the ionosphere for the same. And you can see from this graph that at this altitude range, there's a steep temperature difference zone. And using this equation, it can be easily proved that the temperature difference, which is heavy, can be used for generating current required amount of voltage. Now, let's go to the next, which is catching of free electronic charges. Here, you will be having a plate which is similar to a solar panel on which electrons will be getting accumulated, and through this continuous process, we can generate necessary amount of energy. Of course, the next one is a natural thing, which is the solar power, and that will be discussed in the next model.
Yes, we have invented the model. It's a space power station. And let's look at what is that.
The space power station consists of two satellites, satellite number 1 and satellite number 2. Per satellite, we will be having panels for catching electrons in ionosphere and 4 panels per satellite for use of thermoelectricity, as well as 2 movable panels, solar panels. Now, by using the temperature gradient that exists, that is T2 greater than T1, by using this temperature gradient, thermoelectricity can be generated by forming a closed circuit here. Means the panels of second and first satellites will be connected through a nanowire, and by using this closed circuit, you will be able to generate electricity here. And let's look at the panel for electrons. Here in ionosphere, there are a huge quantity of electrons, and these electrons will be getting embedded on this, and energy will be formed here also. Also, the solar panels will be used for harnessing the rich solar energy. So energy from the three sources are now harnessed in the system. Now the natural question arises, how to transmit the energy? Of course, it's illogical. You can't have wires for it. Yes, we are having an innovative method. For transmitting energy, we will be using a microwave of 2.4 gigahertz frequency, so that it can be beamed to any part of the world. The positive system with this is that if microwaves of 2.4 gigahertz are used, it won't create any environmental problems. Along with that, it can be given to any part of this world, providing an accessible energy to every people on the surface of.
Okay, now the third section, costing and estimation. We should first remember that per square kilometer area of the ionosphere, around 1.4 gigahertz of energy is coming. If we are able to harness at least 1% of this energy, it will be providing nearly 100 gigawatt of energy for this whole world. And for the same, now comes costing and estimation. You are having 2 satellites, and the total cost will be around 800 million. And along with that, I am assuming a 200 million accessories charge, along with that 1 billion for transmission cost and other maintenance. Total, it's a 2 billion project giving power to every people in this world. Thank you and have a very nice day.